Hello, everyone. My name is John Rodriguez, and I work on the Cash App team at Block, formerly Square. We did the whole Meta thing where Block is the parent company and Square and Cash App are the um, products along with others that are part of the Block Corporation. But you're probably familiar with the Square Cash App brands from the open source community. And today I'm going to be talking about a library that I've been maintaining for the past few years, and it's starting to pick up some really big traction, which is exciting. Just a quick question. How many people happened to see this talk last year? Okay, cool. And maybe did you see the iteration of it in New York about a few months ago? Raise your hand if you saw that. Okay, cool. A lot of new faces. That's great. There is new content from the previous London iteration of this, but I just wanted to get a feel because there is some, not too much overlap. All right, great. Let's get started. So this talk is going to be talking about snapshot testing and paparazzi. And so when I started talking about this, Cash App as a product is offered in the UK. It's currently more popular in the US in terms of feature set. We're rolling out several features as we progress to take more of an international presence. But the mission in the moment is to enable payments to other merchants and enabling consumers to manage their money through banking services, lending, investing, Bitcoin. And in order to satisfy these missions, in 2019, the team experienced a lot of growth, and we realized that we needed new tooling to scale. And so after a hack week, we came up with this idea of how can we accelerate Android UI development along with the rapid team growth. And so we came up with this project called Paparazzi. Since then, both internally at Block and externally in the open source community, people have been really excited about using it in their repos because of currently, up until then, the options, which we'll talk about, were limited. It's also become famous at companies like Twitter, Dropbox, Facebook, and the Wear team and Android X team at Google have started adoption, which is exciting. If this is your first time hearing about the project, I'll briefly go over what the premise is, but the idea is tightening the feedback loop between design and engineering. Say you've been assigned to work on the next hot feature and the designer sends you a template in Figma to work off of. You probably, as any good Android developer, are using the compose preview aspect of Android Studio. Maybe you're still using the legacy XML views of Layout Inspector, and you're developing as so. But as you do so, sometimes you'll notice that the Layout Inspector or the preview is either doesn't represent the current state of your app, or it's slow to load for various reasons. And so in order to actually get an idea, a handle of how your view renders, you'd have to build the app and install it on a device or emulator. And this takes a while because of Gradle. And the Android ecosystem in general is pretty heavyweight. This is a, did that click? No, there we go. This is a very outdated graph, but unfortunately there isn't a better updated graph. And so this is just how we show the Android build tool chain of what goes on. Compiling classes, compiling resources, dexing, ProGuarding, all that. It's very heavy, and in order to just see the one screen of your app that you are trying to get an idea of whether it renders to spec is pretty challenging to do. The feedback loops are just too long. We have a team of fairly expert Gradle gurus, and so even by working on, if you saw my earlier talk with Tony, we talk about Gradle things and optimizing it all the time. And so even with optimized Gradle builds, it's still a slow feedback loop because of just pushing an APK to a device or emulator. And so now it's on your device and emulator, and now you have to hunt for the screen. It might not be the landing page. It probably isn't. You might have a server-driven flow. You might have the screen you're trying to test behind a feature flag. Maybe staging is down. There's just so many obstacles. And the whole idea that I'm trying to paint is this isn't a problem unique to Cash. This is a problem unique to all developers that do Android around the world. All of you have this, probably face this every day. And so the premise was, back in 2019, Jesse Wilson and I started digging around in the Android Studio sources to see how does layout preview work? What is it exactly that How does it work under the covers? We notice it doesn't work all the time, but can we bridge that gap and maybe figure out how to make it work for us? And so we started off as any hack week. We just started copying jars, private APIs over, and with a little bit of refactoring, by the end of the week, we were able to extract the core bits and borrow some ideas from the Android Gradle plugin so that we can now run a full snapshot test on an Android platform on a JVM, as opposed to the full Android build tool chain. And so, as always, mileage may vary depending on how your app is laid out, but in the order of seconds versus minutes is a pretty good win, at least for that hack week at the time. So now instead of running all the bits of the tool chain, we really run a small subset, pretty much to compile layout resources in the legacy view world and to populate UI with view model data. So how does this library work? So if you haven't seen it before, this is how you get started. It's a JUnit rule, so you instantiate it as so. And if you're, again, using layout XMLs, you'd inflate it as so and call snapshot, and that's really it. That's what I just went over. If you are instantiating your views directly, you can also do so by passing the Paparazzi's context. And if you're using composables, there's support for that as well. So by default, there's a development mode that the idea is that in case preview is just slower than you'd like it to be, you have an option of working in this development mode, which will show the series of renderings that your app development undergoes. And so you can see a timeline of this. If you are satisfied with how your view is rendered, you can now record it. And this records a golden value into something that you would probably check into your source control, probably using something like Git LFS or an NFS share that will be a repository of golden values for your snapshots. And then on CI or maybe locally, you will run the verify task that will compare the current state of the view to the previously recorded golden value and assert whether it worked or could not. Things like test parameter injector by Google make Paparazzi tests even more powerful. Because now you can start to, as implied, parameterize your tests with different device configs. So your Pixel 5s versus your Pixel 6s, your XLs versus your normal size phones, or different themes, or whatever your heart desires, as we'll go over. Here's an example of such, how just by providing two enums and providing the backing values for them, a test can now be representative. And here's how we pass the state to the test. You can now have a variety of permutations of snapshots. Paparazzi also has a nice side effect of forcing you into architecting your views in a certain way that I'll go into. Now, without going into too much of how Cash App architects its app, we have a concept. We have a library that's internally nicknamed Broadway because it manages scenes, like theater scenes. And so what it essentially does is it's a combination of dagger multi-bindings and the idea of that when you're in a certain module, given a POJO representing or a COJO representing what screen you are with arguments, there will be a presenter factory and a view factory, which will respectively find the presenter and view that map for that POJO. And then the multi-binding will associate them with each other in a cyclic fashion such that user interactions are represented as UI events, and the resulting models or side effects are represented by UI models. And so if you, I don't know if the videos have been published yet for NYC, but if they have, there is a much more deep dive talk of how we do our architecture on Cash App that I'd encourage you to go watch. But it's not necessary for this talk. Just know that we have an interface that represents the view. And so that allows it to be used in a multi-platform way. We don't have to necessarily know that it's an Android view. It could be a CLI. It could be an iOS NS view. But it's backed by this interface called UI that specifies the contract. And similarly, we have a contract for the presenter side. So here's an Android view. And the Android view will implement that interface. And one of the things that is part of that contract is the ability to pass their view a model. And so if you abide by this contract, now you essentially, for free, have made your Android view or composable simplified. It's a dumb view with getters and setters, as it should be, no business logic or any of the sort. And so by doing so, your Paparazzi tests will become simpler, just as a byproduct. Internally, we have a Snapshot browser which now allows us to catalog for designers or for onboarding new engineers what the state of our app looks like, which is pretty powerful as we continue to grow the team. Okay, so that was kind of a high level of how do you use Paparazzi if that was the first time you've seen it. Now let's look behind the curtain on how it works internally. So Paparazzi, as I mentioned, is a JUnit rule, and it works. The magic behind it is this library called layoutlib. Layoutlib is the internal APIs that drive the layout inspector and the preview feature of Android Studio. And if you look in the open source repository, you'll see that code. Layoutlib is layered over, and I'll explain more on that, the Android framework. And underneath that is some concept of a delegate model. Let's dig in more into Layoutlib. And so if you've been doing Android for a while, Layoutlib has been around since API 5, when Android Studio wasn't even a thing. Eclipse was the predominant IDE at the time, and before the Android Gradle plugin, there was the really cool Maven Android plugin. But now, even though IntelliJ and Gradle have supplanted as the tool of choice, Layout Inspector is still around. And so if you dig around the Android framework, you'll see that there are native calls to interact with sensors, hardware sensors, and other device-specific things. How does this work in the IDE? If you look at the sources of Layoutlib, you'll see there's this thing called Bridge, and it represents essentially the Android ecosystem, the idea of build properties, where your files are, all your calendar and time data, and as well as some platform-specific attributes. From the bridge provided by Layoutlib, you're going to instantiate something called a session params. And when I say you, really Paparazzi handles this under the covers for you, but if you were so inclined to understand how Layoutlib directly works, this is how it works. Session params now represents your app, in a sense, the app shell. So it has the idea of the content root and what device will it render on, what's this, will it be a horizontal scroll or a vertical scrolling app? They'll have some idea of a callback, and you'll also have to feed it the idea of what your min SDK and target SDK is so that it can figure out how to look up the resources appropriately. Given that, you'll now instantiate a session, which is going to be now the combination of both the Android environment and what's representing your app. And from that, you're going to pass it a series of views or composables in taking snapshots and result in a rendering. Given the fact that you can mock out the choreographer clock, you can also do animations in a video format. So this is how Bridge looks, and we're not going to go into all of Layoutlib, but some things to note there is that the render session that powers this has some concept of mocks. Instead of the Android context that you're familiar with or context impl, the Bridge class provides an internal implementation of context called a Bridge context. Makes sense. There's also things for layout inflation and for parsing resources in general. And what you'll notice is that instead of the XML pull parser that handles the binary resources that would be packaged inside of an APK, this parser deals with text formats. And so if you're familiar with how Android internals are package your resources and you just unzip your APK, you'll see that, again, how resources will be packaged. And my laptop is beach bowling. Great. So now if you look at one of those resources, here you go. You'll see that packaged in the APK, the resources are bundled in binary format. But yet you can still see some of the attributes embedded in there. So why binary? Well, it makes the APK smaller, faster to parse, launch speed, all the things that are good for like performance. But in your IDE, technical problems. Hold on one second, please. I think I'm having a laptop issue. Keynote. All right, I think it finally caught up.
You just gotta make it full.
Yeah. I'm just seeing where I was. That's where it was. Okay. Oh no, I need to plug this back in. Yeah. I don't know what was beach ball in it, but for some reason I unplugged it. Okay, thank you. Where was I? So yeah, the binary form of the resources will result in a more performant app. It's not beach balling, but the clicker is not responding. Do I have another click by chance? I don't know if it's a clicker or if it's my lights or whatever. But let me see if I could. No, it could be just Keynote, because Keynote tends to do that. Okay, that seems to work. It's just probably Keynote having a memory leak. Cool. Sorry. It's all right. All right. How much time do I have? Just so my clock is off now. Okay, so binary resources. But in layout lib, we can bypass a lot of that compilation because we're reading off of the file system, right? We don't have to run APT, we don't have to crunch resources. We're reading directly from the file system. Let's talk a little bit about now the delegate model. And so because of the fact that there's going to be on a device or emulator native code that is run that otherwise would not be running your IDE, there's a process to create layout lib from the Android framework called layout lib create. What this does is, using some DSL configuration, the Android.jar, the framework jar, is actually bytecode processed, and certain methods are intercepted. For example, if we look at resources to get drawable in layout lib, every time you look up a drawable, it's intercepted by layout lib and routed to a delegate method that will have a completely different behavior than it would be in an APK. In this case, this would make sense since you'd want to, instead of using the binary parser that would be in an Android framework on a device, you want to use layout lib's version. So things like this have to exist in order to use most of the code path, but not all of it. If you look inside layoutlib.jar, you'll see that that delegate pattern is used fairly often. Now, I mentioned that some of the native framework of the native part of the Android framework is stripped out using the layout lib create, and this was mostly true until about like a year or two ago, maybe a year and a half. And part of this was because the graphics rendering of Android was not rendering 100% pixel perfect in the IDE. A good example of this is you probably couldn't visualize the difference between these two screenshots, but now if you overlay them, you can. Things like text spacing and line heights using the Java AWT toolkit in Android Studio didn't map one-to-one with how the Skia graphics pipeline on a device would run. And so the Android Studio team decided to solve that by packaging the Skia the graphics pipeline into layout lib, which now means instead of having a purely JVM artifact, layout lib is essentially a JNI bootstrap, and it will run machine-specific code to do that, to run that scale pipeline, and it has to be compiled for the specific chipset you're running on. Looking into the Paparazzi rule itself, you'll see that it aims to be configurable to however you want to test your app. It also tries to provide reasonable defaults. For example, depending on what mode you're running in, it'll determine what the method of the implementation of a snapshot handler. Are you verifying your snapshots that Paparazzi just took to something of a golden value from before, or are you writing to the file system for reporting? A lot of those reasonable defaults come from the detector detecting the environment. So with the help of the Android Gradle plugin, it's able to infer where the location of your Android home is or where resources are to bootstrap properly. And following these conventions will reward you. If you're familiar with how RoboElectric used to require properties files, the environment tries to provide that equivalent where it finds where the Android platform-specific parts are. But instead of providing the properties directly as RoboElectric used to require, we use the Android Gradle plugin in order to get those bits. And so one of the things that Paparazzi provides is a Gradle plugin that hooks into the Android environment, specifically looking at the compilation of code and the merging of resources, and wires itself between those two tasks. It does similarly for Java and assets. Once it does that, it looks specifically for where the resources wind up. So one thing that's interesting to know is how are resources merged on Android? Your local module has resources, sure, but it could also have a dependency on another module that also has resources, or it could have a dependency on an external artifact off of Maven Central, an AAR, that also bundles resources. And so how does that work? Well, it turns out AGP will merge all those resources in each module, the transitive resources, and put it in this directory. And so Paparazzi decides to look there and find where all those that location is located, and then writes it to this resources file, so that later, when Paparazzi is running it as a unit test, it can know to look there for that value. And so Paparazzi can run in several modes. At the end of the day, it's still running a JUnit test, but whether it's doing record or verify is set using system properties. What that means is now, instead of having a test dependency similar to like how you would do assert J, JUnit, or truth, instead you would just add the Gradle plugin, assuming you use Gradle, which most of us do, and it'll do the work for you. Now, because there is a native component to this, let's talk about how layout lib is packaged in AOSP. Currently, we're not building from source, mainly because the way that AOSP builds its modules is a bit different from how Paparazzi builds its projects. As a result, we're relying instead on the pre-built. And so the Google monorepo checks in its binary artifacts into the repo as well, as opposed to it basically compiles it from source and then checks it into its repo. And so what Paparazzi does is it checks out the pre-built from the repo and repackages it. And so if you do a quick tree of the hierarchy, you'll see that here are the machine, the platform-specific binaries backing layout lib. What we do then is we package it internally and push it to Maven Central. But there is a work in progress at Google because of the value add that they see in fostering a library like Paparazzi is potentially now taking that once private API in layout lib and just publishing it on maven.google, similar to how some of the other repositories were. This came up in a recent Android Dev Summit discussion, and it's pretty exciting to see that they're willing to publish this as a separate artifact. If you're interested, that's the issue to follow. In the meantime, because this process does not exist, there's a bit of a weird deployment process that we have to undergo, where we have to publish the platform-specific jars separately. And then, given the way that Gradle the Gradle caching system works, it's gonna have you're gonna download this from Maven Central as a platform-specific jar, but then eventually you're gonna have to pass paths to this bridge. So how does this work? If you need to pass specific paths that get downloaded in a jar, well, that's where Gradle again comes to the rescue. Using this concept called Gradle transforms, which is simply similar to how Jetify works, how Jetify can download something that was referring to the old support lib packages, and then on the fly rewrite not only the bytecode but the resource package names. You could also write your own transform to pretty much do anything to an external dependency. So in this case, we take the platform-specific dependency and unzip it and put the files in the right place so that we can pass those file paths to the bridge as opposed to class loading it. And if we look under the transforms directly, we'll see just that. There we go. So since we support Gradle, a question that we've been getting lately is, do we have any plans to support a Bazel plugin? And their answer is not directly. However, there is support from Uber looking into doing this because there's, you may know that they're a very heavy, previously Buck and I think now Bazel shop. So we've been collaborating with the team over there, the platform team. So for now, we'll just say coming soon. Let's talk a little bit about accessibility. So Paparazzi, again, in combination with test parameter injector, makes this fairly easy. By just providing us, your respective font scaling and wrapping the Paparazzi context, you can easily render snapshots. In this case, it accounts for using either a recycler view or a lazy column. And the combination of such can give you some pretty nice artifacts, which will, again, your designer will be pleased that you're considering such form factors as well. Another thing that we provide in Paparazzi is this concept of a render session, which is how accessibility is currently supported for legacy views. And what it does is we intercept it. Think of it like an interceptor model where the render extension will take whatever the snapshot from Paparazzi results in and apply some layering. And so this was a teammate's project. Jeff, he worked on implementing this, and so there's an analog for iOS that does the same. If your iOS developers are interested in something like that, we have a library called Accessibility Snapshot. This is how it looks if you use the accessibility render extension. It'll still render your view hierarchy similar to how Paparazzi would have done, but it also adds this legend and some context around whether you're setting things like content descriptions or talkbacks. So check it out. As you can see, the only thing you need to do to implement it is add a extra little bit of configuration to Paparazzi and you get it for free. One thing to know if you were interested in contributing to Paparazzi is that layout lib bugs become Paparazzi bugs. For example, we do a fair amount of 3D graphics using filaments to render our cache card. And a while back, we had this interesting scenario where the card wasn't rendering. And before I talk about how we solved it, well, more specifically, the means by which we solved it was by using the same thing that Roboelectric and Marketo used, which is this library called ByteBuddy. And essentially, we had to do the analog of shadows, Roboelectric shadows. So in the case of the cache card, the bug was with layoutlib, many of the native calls are swapped in by that delegate model that I mentioned. But sometimes some of those native calls don't have a backing delegate. It's just a no-op. It just wasn't a consideration by the team at the time. And one of those things happened to be matrix operations, specifically multiplication. And so using this ByteBuddy interceptor model, we were able to, anytime you called the multiply mm or mv func method on the OpenGL matrix class, we intercepted it and literally copy-pasted the Roboelectric shadow implementation in order to satisfy that. We do something similar for fonts because we are only able to, layoutlib only works by bytecode processing Android framework classes, not things like Android X classes. We also do something to intercept is in edit mode because unlike the approach taken by Layout Inspector, where view is in edit mode would allow you to bypass certain execution paths. And on Paparazzi, we want you to execute your view as you would on device. We don't want you to swap out the business logic. We want you to pass a model and treat it like it was production code. And so in order to do that, we kind of have to toggle the Boolean in the other direction. We mentioned that compose support is now provided. This was interesting because a lot of the ways, like the monatomic frame clock of compose is still backed by a choreographer, so you get it for free. And there's some commits that talk about that. Let's talk about some future things for Paparazzi. Despite the fact that preview itself tends to render slow in the IDE, at least we've been experiencing that on Cash App. We're about 800 modules in a big team, so it could be just a scaling issue. We are interested in seeing whether we can reuse previews from Android Studio and auto-generate Paparazzi tests, since they tend to, not always, but they tend to share commonalities in terms of you want to be able to render it while you're developing and then simply have a backing test generated as a result. And so we've been working on something like that using an approach similar to Airbnb Showcase and Kotlin compiler plugins. There's a proof of concept PR open on the repo, and we're hoping to get that in soon. Let's talk about another thing that's been that's under works at Paparazzi. I kind of alluded to this earlier, but resources in Paparazzi are very important. We don't run AAPT, but we still need to be able to refer to every single resource that a module would in an app, whether it's provided by a third party or not. What's interesting enough is that if you enable non-transitive resources, this doesn't become any easier, because now instead of having one global R class, you have several. What Paparazzi does either way is it basically class loads every R file that exists in the file system so that it can get those public static final integers, the indexes, into your resources file. And it needs to have that in memory, because the same resource lookup mechanism that works on Android has to be used by layoutlib. One decision that we made back then, as I alluded to earlier, was having one place to get all our resources. And so the way that we did that was by peeking into AGP and seeing where it has its output folder for merged resources. Unfortunately, this was a mistake. It was a great way to kind of make forward progress on a hack week, but it's starting to incur a bit of technical debt. And I mean, part of the reason for that is you really shouldn't be peeking into the internal details of how any third-party plugin looks. You really should be consuming the inputs or straight-up outputs. To do so, though, at the moment would mean rebuilding how resource merging works on Android, but in another fashion, so that Paparazzi can walk this graph. Because again, AAPT is not available. For example, one side effect of this tech debt is you may notice that if you use Paparazzi, you can't use it in an application module. You're limited to using it in an Android library module. Well, why is that? Well, because that merged resources directory that we peek at is a text file in library modules, but it's a binary file, a proto file, in application modules. And we didn't make the effort to reverse engineer the proto file format. We just kind of said, all right, well, move the things you want to test into a separate module. And that's kind of a nice workaround, but at the same time, it's not great, because if you wanted to use Paparazzi, say, in a demo app, you can't. You'd have to make a modularized version of your demo app, and that seems silly. And things like open source samples as well, where maybe that would justify a single module project. Another thing that's broken because of this is the way that HTML strings work. All right, so how do we fix this? Well, the way that the layout inspector currently does it is it leverages the IntelliJ PSI model. If you're familiar with lint and what PSI is, or even if you're not, think of it as a way to crawl through your source in real time and form an abstract syntax tree explaining what parts of the source are what. Like what's a method list, what's an argument list, what's a type. And by walking something like that, but in the file system, we could use the same means that Android Studio does in order to infer where your source main res or source debug res are. There's an open issue tracking this. It's one of the things that I'd like to tackle by the end of the year. Moving back to this, I mentioned that kind of Paparazzi is a JUnit role, but what's kind of becoming a priority for us is what if we can rip the rendering parts of Paparazzi aside from outside of the JUnit role, decouple them, if you will, and use the rendering possibilities of Paparazzi for a different purpose. So for example, we have very server-driven UI, and so these are two different screens in Cash App, but they share a commonality. So therefore, we have a proto that defines an icon, a title, a subtitle, a primary button, and labels. And this is really the same proto implementation with different metadata. And because we have this, we then have something to help our server team by having drag and drop elements on a web page. And then with these drag and drop elements, the server team can render what we call a form blocker to represent this. By hooking up an IDE, we actually have a KTOR server running in the app in debug mode so that the server engineer can hook this website to that emulator. But that's not great, because now your server engineer still has to download ADB and emulators and basically do Android onboarding. And as any of us know, like that's something you want to do once and not often. And server engineers dread doing this, and designers don't probably want to even do this. They just want to see if it renders on a device so they can make iterations. So what if we can now not just use Paparazzi for internal development tasks, but also enable server eng or designers to see renderings in real time without having the same toolchain problems that we have. So we have a proof of concept of this right now. What we did is we're making instead of that web page, we're making a Jetpack composed desktop app, thanks to the libraries of JetBrains, and seeing if we can take that JUnit rule stuff and just reuse the rendering bits and render a Android view in real time in a desktop app. And I think Uber also has similar desires for rendering, and so if there are other use cases that you could think of, talk to me after this. We just released 1.1. We're excited about that because that brought locale support, RTL, and Google Where support to Paparazzi, something that was severely lacking. One of the lead of the Google Where team, I believe is based out in London, has been contributing heavily to that, so kudos to him. And that's all I had. It's not only are we talking about snapshot testing, but we're looking about doing a whole lot more in Paparazzi. So if you have any use cases or just have questions, let's chat on the side after this talk so the next speaker can set up. Thank you.